Okay, welcome to TechCast episode 6. We're going to call this episode Signals from Space for the reason that we have a new signal from space to talk about. Before I dive directly into that, I'm actually going to take this opportunity to plug what I think is one of my favorite science fiction movies of all time. No, it's not Star Wars. It's 1997's Contact, starring Jodie Foster and Matthew McConaughey.
All right.
And the movie explored kind of how humanity and civilization would respond to a confirmed contact with an extraterrestrial intelligence. It was a very cerebral movie. It was very well thought out. One of the things I like about it is it got a lot right about what scientists then and today believe that first signal would look like. And that really should come as no surprise when you find out who the writers of the screenplay for Contact are. None other than famous astrophysicist Carl Sagan and his wife and longtime collaborator Andrew Yan. Drew Yan and Sagan have just a history of collaboration going back into the early 1970s. One of the first projects they worked on together were the Voyager space probes, and their contribution to that project was in the form of a gold-plated record, which contained sounds from humanity, greetings in several languages, personal messages, and printed on this record were carefully designed illustrations that were meant to convey that we are a civilization that understands science, astronomy, mathematics, and we might be somebody worth making contact with. After Voyager launched, Drew Yan and Sagan collaborated again on something you may have seen, the 1980 hit documentary series Cosmos, which aired for, I believe, 12 episodes on PBS. And if you haven't seen Cosmos, I highly recommend you look for it on a streaming service, or even if you search around the internet, you will find episodes out there. It was a very well-crafted exploration of humanity, the natural world, and our relationship to it, and sent a very hopeful message about humanity and our progress towards becoming a civilization that grows beyond our home planet. Now, between Voyager and during Cosmos, Drew Yan and Sagan also began to work on the screenplay for Contact, and they were hopeful that with the success of Cosmos, they could get a Hollywood studio to pick up Contact and produce a feature movie for it. And there were some initial conversation with studios, but creative differences, technical differences, and frankly, the unwillingness of studios during the 1980s to take on a serious hard sci-fi movie led to one thing after another. So finally, in 1985, Sagan gave the screenplay the novel treatment and published it. And it was very well received. I believe it got a Hugo Award. And that allowed them to kind of keep poking around Hollywood to see if somebody would pick it up. But it would still be 10 years before they found a serious champion. And that champion would be Robert Zemeckis, who's probably best known for the movie Forrest Gump. And yeah, actually, Forrest Gump is the movie he made right before Contact, which was, it was a fun movie, and it gave him the pull within Hollywood to name the script that he wanted to direct next. Another thing I like about the movie Contact is that one of the lessons from Contact is that we as a species, as a civilization, we're simply unprepared for what may be the eventuality of a contact with an intelligent species from outer space. In the movie, you generally see people go nuts and run around in circles for a little bit. And I think that's very much true of what we would generally do today. We have no serious policies. We have no good policies, I should say, about how to respond to this. Now, in 2010, the United Nations Office of Outer Space Affairs, they committed to developing a policy and publishing it. But I've been all over their website, and as of 2018, it seems like they're still maybe working on a policy, but we really don't have a good policy out there right now. Now, I keep saying a good policy. We do have a policy in general, and it dates back to the 1950s in the UN Security Council. And their concern is that a technologically superior civilization would overwhelm us militarily, and we would be destroyed, enslaved, or, I don't know, eaten by the lizard people. Whatever their justification is, their policy is that in the event of a confirmed contact, we would turn off all of our radio transmitters, turn off all the lights, and pretend like there was nobody home until we were sure that the threat had passed. Let's talk about signals from space. Now, over the years, radio astronomers have looked in earnest for signals that would indicate an extraterrestrial intelligence, and they have actually found quite a few signals, candidate signals, but they're usually explainable in terms of natural phenomenon, more commonly terrestrial sources. We are pretty noisy. We have a lot of people operating radios. We have a lot of satellites in space. And then even when all of those are ruled out, it's oftentimes discovered to be some natural phenomena that we previously didn't know about, which disappointing for alien hunters, but still really good science. So in 1977, a few years before Sagan and Druyan were working on the script for Contact, there was probably one of the most interesting signals so far. Scientists working at the Big Ear Telescope at Ohio State University, they were doing a survey of the sky using an IBM computer to analyze the incoming signals and measure them across a number of dimensions and categorize them according to categorical scales they developed themselves. These signals often weren't heard live, but instead were reviewed in the data a few days later. One such signal came through that was particularly interesting in 3 dimensions. The first dimension was the relative power of the signal. It was some 30 times louder than the background noise in that area, which indicates a very strong and very direct source for the radio signal. The second property of the signal that was very interesting is that the best way I could describe this is it started out low, grew in intensity to a certain peak, and then kind of fell off intensity after that. And this is what you would expect to see from a very directional, very strong signal, that maybe the transmitter is turning, and as it turns towards you, the intensity increases, and then as it turns away from you, the intensity falls off. I think the best metaphor would be one of those rotating air raid sirens you see in the movie, and as the horn rotates towards you, it gets louder, and as it rotates away from you, it falls off. Very much indicative of a purposely built transmitter antenna. Now, of course, there are natural phenomena that follow that, quasars and pulsars being one of them. But the third thing that's actually kind of spooky is the frequency that the signal was received on. It was very, very specifically on 1,420 megahertz. And why that's important is that is the natural emission frequency of hydrogen. It's actually called the hydrogen line. And it's speculated by a lot of scientists that if you had an extraterrestrial intelligence and they did want to reach out and make contact with other civilizations, they would choose that frequency because hydrogen is, for one, it's a fundamental element. It's the first element on the periodic chart of elements, and it's also the most abundant element in the universe. Now, the scientist that was going over this data and first recognized the signal, he recognized that it was a very significant finding. In fact, so much so that he circled it and wrote the words "wow" in red ink next to the circle. And ever since then, it has been known as the WOW signal. And to this day, the WOW signal remains probably one of the strongest candidates. It could not be traced to a terrestrial source known at the time. It could not be explained in terms of natural phenomena, and scientists are still looking at this and trying to explain it. Now, one of the downsides to the WOW signal is that it was detected once and only once. And one of the limitations of the big ear antenna that they used is that it could not look very precisely to one part of the sky. And by its construction, you couldn't be sure which part of the sky it was looking at. And I have an image I'll throw up here, and what you'll see is the overall area that it was surveying was pretty large. And then there are 2 red ellipses which describe the area in which the probability of signal being received from is the greatest. Nothing in those areas is particularly interesting. In fact, for many years, we didn't even know whether or not there were sun-like stars there. We only recently discovered a sun-like star candidate. We still don't know if any of those stars contain planets. And so it's still very much a big question mark about whether or not the signal was some kind of fluke or whether it was an intentional signal from a likely extraterrestrial civilization. So this brings us to where we're at now. As of the close of 2020, we are getting reports in the media of a signal that was detected back in 2019 through the Breakthrough Listening Program. And the signal is referred to as Breakthrough Listen Candidate 1. It was picked up by the Green Bank Telescope in West Virginia. Some of the advantages that BLC-1 have over the WOW signal is that, for one thing, we pretty precisely know where the signal came from. At the time the signal was received, the telescope was pointed at relatively close neighbors of ours called Proxima Centauri. And we know that Proxima Centauri is orbited by 2 Earth-like planets, Proxima b and Proxima c. Proxima b is actually considered to be a very good candidate for a potential Earth-like planet that could host life because It orbits Proxima Centauri in what is known as the green zone, which is where they would expect to find liquid water. There's also evidence that Proxima b has an atmosphere. For another, we can pretty well rule out terrestrial sources of interference. The Green Bank Observatory is actually in the middle of the National Radio Quiet Zone. It's about a 13,000 square mile area in Virginia, West Virginia, where you're not allowed to operate a radio transmitter. So that pretty well rules out a lot of terrestrial radio sources. Also, because that facility is jointly operated by the United States Air Force, NASA, and the National Reconnaissance Office, they have quick access to rule out any kind of satellite sources. Something else which is pretty significant is that the signal was detected more than once. And so what radio astronomers do today to try to rule out terrestrial interference is a process called nodding, where they'll point the telescope at a source, observe it for a little bit, and then they'll point it away for another period of time to see if the signal goes away. Then they'll point it back at the source to see if the signal comes back. So a lot of forms of terrestrial interference are going to either not be there the second time, or they're going to have a different characteristic signal as a result of the nodding. So BLC-1 was detected not just once, not just twice, but in a 3-hour period with six opportunities to observe it. The signal was detected 5 times. Now, this is all the information we have from news media sources at this time. The scientists who detected the signal are working on a paper to be published sometime early this year. If the signal does appear to be some kind of intelligence, this is extremely exciting because Proxima Centauri, if I haven't already mentioned this, is only 4 light years away from Earth, which means if there is a civilization out there, we could have meaningful exchanges of information by radio over a very short period of time. So 4 years for the signal to get there, 4 years for a signal to return. And also, even though we have some primitive spaceflight capabilities right now, we do have some technologies that are feasible given our current state of the art, where we could actually send a space probe out there or send something out there, a care package or whatever, and it would get there within a single human lifetime. Now, I want to be cautious because as interesting as it is to want to believe that this is a extraterrestrial signal, there is at least one potential source of terrestrial interference. The signal was received on a frequency of 982 megahertz. And this is the range of frequencies which we operate navigation aids for aircraft on. It's something known as a distance measuring equipment beacon, or DME beacon. However, what allows us to rule out a DME beacon potentially is that while the signal from Proxima Centauri was a simple carrier wave, a DME beacon would actually have information encoded on that carrier wave through modulation. And the signal, from what we can tell, had no information modulated onto a carrier wave. Also, something that helps out is that DME beacons are very directional. So the telescope would have had to been pointed more or less on axis towards the DME beacon. And since these beacons are on the ground pointing up and these telescopes are on the ground pointing up, they're not going to be pointing towards each other at the time. And also, as I mentioned, the telescope is in the National Radio Quiet Zone, so there are no DME beacons that are appreciably close to it. Now, sometimes radio waves have been known to reflect off of the atmosphere, but at these frequencies, those reflections don't occur. And then probably, I really don't want to mention this, but there is another wet blanket to discuss. Back in 2016, astronomers observing Proxima Centauri saw a solar flare. Proxima Centauri is a red dwarf, and it's extremely active. And the solar flare that was observed was pretty significant, such that if it struck Proxima b directly, it would do significant damage to any life down there, particularly if it's a technological civilization. Now, other scientists speculate that because it's close to its primary star and it probably has an orbit, then it also probably has a magnetosphere which would protect the planet from a solar flare. So again, there are a lot of what ifs concerning this signal. Hopefully, we'll have that paper out early in 2021 when we can satisfy our curiosity, and potentially maybe we'll see another signal again in the near future. So again, a lot of information. I'm going to include a lot of links in the description below. Please review it and make up your own mind. So that's it for this episode of TechCast. If I didn't completely bore you, please go ahead, click like and subscribe. Or if you're watching this on Rumble, click that little plus button down there at the bottom of the screen and that subscribe button somewhere above the window here. And until I make another video, thanks and have a good week.